Google? Don't talk to me.
Okay, so this is the audience for looking the wrong way.
No, I'm looking. I'm looking your way.
Are you part of the class? Yes. We're going to get started now. All right. So I have my volunteer here recording me
With the Google Glass.
So that we get the kid's eye view of this, and if it works out, I'll post that to YouTube. Okay, so let's start. What's this talk about? So who here studies science at school? Do a little bit of science? Yeah? So what kind of science do you do?
At school, in sixth grade, we usually do nature and the animals.
Science, there's like chemistry, right? What other kinds of science?
Look at the molecules and stuff and structures of it.
Okay, so that's biology, chemistry, there's sort of physics. There's all these kinds of science that you study in school, but probably don't have data science in school. So I'm going to try and explain why this is a very new kind of science that's only happened recently. And then I'm going to tell you why it's interesting, why you might want to be a data scientist one day, and then why you can actually learn to do that by only spending $1 or so. You know, it's very, very cheap to learn. So that's one thing. You do. I'm going to sit there to get closer. All right, good. So the point about data science is that they measure everything, right? Everything now is measured, like and being measured by this Google Glass here. It's like that's collecting data, it's collecting video. The world is measured. Instead of going out, if you think about it, in the old days, they had if you wanted to measure the temperature of the world, there were little thermometers everywhere in the world, and once a day, someone would go and measure the temperature on the thermometer, and they'd write it down on a piece of paper, and they'd take it away, and then later they'd type it in, and that would then be logged as like the world's temperature. So nowadays, I have a little weather station at home that measures the temperature all the time. And your car is measuring the temperature all the time. And everything's measuring over the whole world. And there are millions of things measuring, or maybe billions. And they're all measuring it, and they're all putting that data somewhere. So instead of just having a few things that have been measured by hand, we now have computers measuring everything all the time. So what's happening is there's a big shortage of jobs for people to make sense of these measurements. So this don't worry too much about this, but it says that in 2018 there will be 140 to 190,000 unfilled positions for data scientists. So that sounds like a good idea that everyone should know what this new job is. And this is the graph on the left shows that from the time that most of you were born, there was really very little data science to worry about. Data to worry about. The volume was low, and it's been increasing really, really fast. So this is a new generation. This generation of kids, this is a big problem. And when we were growing up, when I was growing up, adults were growing up, this wasn't a problem. It wasn't something we learned in school. And so we've now reached this point, and it just keeps getting bigger and bigger. And the biggest problem that people have with this is they can't find people with the skills to figure out how to deal with all of this data. So this is your future job. You can be a data scientist, and it's something that really didn't exist before. And this is a graph of people looking for jobs. This is sort of what titles people have in jobs. And you can see the beginning of 2010, so that's only 4 years ago, there were no jobs advertised for data scientists. And then it all of a sudden became a big thing. So it's going up and up, and there are more recent versions of this, but it's now a thing. So really only a few years ago, this wasn't even a job. So I'm going to try and explain a little bit about what it is. Well, the first thing I'm going to do is show you what a data scientist does. There's a guy in England, his name's Mark, and he built this really interesting thing, and I'm going to demo it to you to show you what he does. He built this in his spare time. So it looks like this. Anyone any idea what this might be? Has anyone ever written a mind map where you get all of these ideas and you draw lines between them? This is a mind map. This is a mind map for everything everybody has mentioned on Twitter in the last week. So when you type things, when you tweet on Twitter, you put hashtags in, tag whatever the things are. And what this does is it links together all of those hashtags so that when you look across all of Twitter in the last week, these are the popular things. So I'm going to go to a live copy of this. And this is a program that anybody can run. So here is the program. And we can look around this. So what do you think happened in the last week? Anything that people would talk about on Twitter? So let's, huh?
Ukraine.
There's the Ukraine. Ukraine's a bit older than that. I think a bit more. Let's do Easter. Let's try Easter, because it's Easter time, right? There's Easter, right? So here's Easter. And people have happy, family, fun, funny, Holy Week, bunny, eggs, Good Friday, chocolate, and spring. So that's all the stuff to do with Easter that's on there. And then over here we can see there's music. Music's a popular one. There's lots of people do music, entertainment, all the different kinds of music. If we scroll back out again, you can see all of these things, all of these words. It's pretty complicated. But down over here, there's this whole area that's just slightly connected. What do you think that might be?
I think that's a sock.
It's sock. Kind of looks like a sock, maybe. But if we go look at this, if I keep scrolling in on it, eventually we see why this is separate. Look, this is all in Arabic. This is, I think, actually I don't know where this is. Bahrain, Saudi. So there's a whole part of Twitter where people are talking to each other in Arabic, and there's a lot of activity there. I have no idea what they're talking about. But this whole section, but they don't tend to mix Arabic with English words. So it's off on its own. So you've got this really interesting way to view it. So anybody can go to hivemindmap.com. So the hive mind is the collective mind of everyone in the world, and it's a mind map. So you can go to hivemindmap.com, and you can rummage around and see all of these cool things. So there's something that South Korea, there was a ship that capsized, a lot of people died, so people tweeting about that. Ukraine is somewhere on here, I think. If we find the Ukraine, we find this other thing, that there's the Ukraine, and then I think this is probably Ukraine in Russian, because then there's a whole lot of links that are in Russian. So, okay, so let's go see, I want to see a little bit, oh, the other thing I can do here is see, this is the timeline of activity. Here are the top tweets about that. Here's related tags. This is all in Russian, of course, and the users that have been tweeting about it. And then you can get, there's all kinds of things you can do. So this is quite a clever little app. So Mark Harwood made this. He has a presentation called Revealing the Uncommonly Common, which is where I saw this. He preaches it as part of his talk. And what he does is he shows connections where the thickness of the line shows you how strong the connection is between them. He fills out the tweets. He shows you the time of the tweets. There's even got a calendar that summarizes when these tweets happened. And how did he build this? He built this out of a lot of free software. This comes back to that you can do this for $1. This is free. It doesn't even cost $1. So he used a bunch of pieces of software which anybody can go and get and use. He used free data because Twitter lets you get a feed of what's happening on Twitter for free, but it's only 1%. It's not all of Twitter, it's just 1%. He rented a server for a few dollars a month to do this. And then your web browsers can generate these nice visualizations. You can see it nicely. And then he got help from people helping him make it. So he went to a place called Stack Overflow where you can ask questions and people will help you. And then he just has the imagination to go build it. So this is a slide he said, there are opportunities in data science. We're generating data that's never been seen before. You can measure billions of people and see what they're interested in, and you could figure out how to sell things to them. You can correct spelling in things. You can look at what's trending in the news, or you could recommend music to people. So all kinds of things you could do. And the tools are incredibly cheap to do this, and it's very easy to get help to figure it out. So this is the whole new thing. So I think it was a nice summary. And then finally, he wrote these slides while he was snowboarding in Canada. It's a well-paid job. Okay, so if you're looking for a future career, this is a job right now which pays well. So how can a kid learn this for $1? This is actually a picture of my son when he was about 10. He's now 29, so a bit bigger than this. But I wanted a picture of a kid, and I wanted one that I owned. So this is a diagram of it's a big data. There's a video here, so I'm going to go show you this video and try and explain what's happening during it. I'll stop this every now and again just to show you what's happening.
sources can help you make transformational decisions. To be able to make these decisions based on data of any scale, you need to be able to access the right kind of tools to process and analyze your data. Software frameworks like Hadoop can help you store and process large amounts of data at scale by distributing the data and processing across many computers.
So what he's saying is that there's this software called Hadoop, and Hadoop was named after a pet elephant that belonged to the 5-year-old son of the guy that wrote this software. So you could have software named after your toys if you persuade your parents to write something. And this software is out there and it's free, but you need lots of computers to run it on. So this guy is trying to process lots of data about the world, and he's got Hadoop in there, and he's got lots of computers behind it, and he's feeding data into it. Okay.
But deploying, configuring, and managing Hadoop clusters can be
He's having a
difficult,
few
expensive,
problems here.
and time-consuming.
It's getting backed up, you see.
To purchase the underlying
He's having to get more and more machines to deal with it.
And then deploy and manage the software. And that's even before you had a chance to do anything with your data. Wouldn't it be great if there was an easier way? Amazon Elastic MapReduce, or Amazon Yin.
So some of you probably buy books and shopping and things on Amazon. So one of the things that Amazon also sells is they sell computers by the hour, and you can buy 20 computers for an hour and pay maybe $1 or $2 for it. In this case, the way you do this for doing real work in real work, in real companies is you might have thousands of computers, but for learning you only need 2 or 3. So you can learn all of these tools using rented machines. You don't have to go and have a big room full of computers to learn to do this nowadays. You can just do it yourself.
MR can make things much easier. Using the elastic infrastructure of Amazon EC2 and Amazon S3, Amazon EMR provides a managed Hadoop framework that distributes computation of your data over multiple Amazon EC2 instances. Amazon EMR is easy to use. To get started, you can load your data and processing applications into Amazon S3. Then you can launch an Amazon EMR cluster in minutes, and the cluster starts processing your data. You don't need to worry about setting up, running, or tuning the clusters. We take care of that, so you can focus on the analysis of your data.
So basically, there's this ability that if you've got a lot of data, you can put it up in this cloud. It's called S3, and then you can create this big cluster to run it, and then you can get the results and pull it back. And it takes minutes to do this. So that's 10 years ago, you couldn't possibly do this. You'd have had to spend millions of dollars building your own computers. And the interesting thing here is that the things that are available to anybody in the world are now basically the same. Would you use a credit card and to spend $2 or $3 to actually get into using these tools? Whereas years ago, it would have taken millions of dollars, and you'd have had to have a team of people to run it. So that's all I'm going to show you. There's a whole lot of training classes and things you can go through to learn to use this, but I'm going to move on so I don't run out of time here. So I was playing around with this over the last few weeks, trying to come up with a better demo. I didn't really come up with a good demo, but all my messing around, I spent 67 cents. So this is my bill so far this month. So this is my, yes, it really, you can do, I spent a couple of days this week playing around with this stuff and spent 67 cents so far. So really, it is not expensive to go and try it. Okay. I'm going to show you something else that's like, so Amazon do this cloud computing, and also Google do it too. We use Google for other things, but let's go find my Google example, which is this one. So Google have this nice application, and they have this fun thing that makes it look pretty, and you can find data from weather stations, or you can search Wikipedia, and they've got an enormous amount of data already loaded into this. So we can go to Wikipedia, and we can look at the top page views. So let's find, I need somebody's birthday.
October 10th, 2002.
October the 10th. All right, so let's go to the 10th. And we want October. Oh, we don't have that. Which year?
2002. And I have another question. Are you going to store my information?
No, I'm not going to store it. Well, it'll be stored on the video. So you're live on the video. So I'll pretend your birthday was in 2010, because we don't have data for whatever year you said earlier. Right? Okay. So anyway, well, 10th of October. Well, we'll just look at what happened on the 10th of October. I know I've got Let's do it. Let's do my, this is, let's just the 6th of October. See what happened then. It's going to go and look at this. It's got this cute demo, which has really nothing to do with it, but it makes it look fun. And it processes it for a few seconds. And then it accesses it. We just looked through 63 gigabytes of data. That's quite a lot. I mean,
My phone's 64 gigabytes.
Hmm?
My phone is
Yeah,
64.
so that'll be, everything that you had on a phone, but it can look through more data than that. Let's look through. Then we've got, so people were looking at Facebook and Glee and Mark Zuckerberg, and the Commonwealth Games must have been happening then, right? So there's a bunch of queries here. The other thing you can do here is look at weather stations, and you can see for anywhere in America what the temperature was in some place. So we can go see what's happening over here, and you can zoom in and let's look at Kansas and see if it's been hot in Kansas over the last few years. Yeah. The highest temperature there is 115 degrees, and the lowest is minus 31. So we're processing this data and figuring out what's going on. Make sure I don't run out of time here. Okay, so I have a few things. I did the Bay Area weather. It's been getting slightly warmer over the years in the Bay Area. And then I ran my birthday on it, which is September 30th, but I put 2010 in because I was born before that. And the Flintstones is the top thing. So why would the Flintstones be the #1 thing on Wikipedia? Why would people want to be looking at the Flintstones?
It shows a lot of history about cavemen.
But why on that day would everybody on Wikipedia be looking at the Flintstones Wikipedia page?
On September 30th?
Yeah, on September 30th in 2010. What was special about the Flintstones on that day?
Movie?
Yeah, there might have been a movie. I don't think the movie came out then. The movie, I think, was a few years earlier. Anyone else know? Well, I know because I was born on the day that the first episode was broadcast, which was in 1960. So it was my 50th birthday, and that was the first. It was 50 years of the Flintstones, and it was in the news that there was 50 years of Fred Flintstone running around and all that. And so I'm exactly the same age as Fred Flintstone. So there you go. I'm old, by the way. So let's just to wrap up. You can actually measure your kids. Right? You've been to school in California. There's data. I can measure you. It's public data on how you're doing. So there's data.gov. There's all kinds of government data that you can get. And you can actually, one of the things on data.gov is the education reports for all the different schools in America. And in California, we can see that there are 10,000 schools in 1,000 school districts and a whole bunch of other things here. And they spend $6 billion on, is that right? No, 6 million. So there are 6 million students and $3.9 billion are being spent on. So that's California. So are we getting science out of that? So let's see. So one of the things you can do is find what is the proficiency scores, the achievements of kids at age 4th grade, 8th grade, and in high school. And you probably went through those tests or you got measured, right? And you can see here that it lists 50%, 30%, they're all jumbled up. So one of these lines is for high school, one's for middle school. I've got the thing scrolls on, so it's a bit hard to read. So what I want to do is process this data. So I'm going to extract it. And one of the buttons you can push there is download it as a spreadsheet. So you download it as a spreadsheet and you get this big list. Now every row in this is a measurement, right? Each individual row is the achievement score for a particular type of school in a particular year at a particular grade, right? So it's 4th grade science in 2008, 4th grade science in 2009, and math, and they're all just in a big list. And I want to make this into some graphs, so I have to I've got to pull this into Excel or a spreadsheet of some kind. We could have to do a bit of cleanup on it, but then we can actually try and draw graphs of it. And here's the first graph I came up with. So this is the complete averages. You can see math is in blue and science is in red across about a 10-year period of the scores. So what can you see here?
That most math grades are higher than science.
looks like people are better at math and science in fourth grade and in high school, but in the middle school, they're better at science. Anything else?
The scores on all the tests start to go down as you gradually on.
Yeah, you get gradually worse as these things as we get older. Maybe there's more distractions in high school. In elementary school, people are more excited about science. Anyway, so, but is it, what we really want to know is it getting better or worse, right? So in this data, I've got it over 10 years. This averages together 10 years of data. So let's look at what happens. Oh, and I'd say about half of students are proficient in math. It's kind of what you could get out of this. That's about what matters here. People going on into workforce, about half of them could become data scientists because they can do math and science. So this is another graph I did. This shows time along the bottom. So that's 2004 at the left through 2012 at the right. Each line on here is high school or elementary or middle school, and the shorter lines are the science ones. So science doesn't go back so far. So what can you see here? Okay. 5-minute warning. She can see a 5-minute warning. What can you see? What do you think? What do you see here? What do you think? It's climbing up. Yeah? It's good. So that's good, right? Means that over the last, whatever that is, 8 to 10 years, students in California are gradually getting better at math and science. And that was the first thing I was looking for. So that's good, right? So what else can you see? What's that dip? There's a dip there in the middle. Yeah, there's a dip in the middle. So what could cause a dip?
And it's almost
the
at the always
dip
at the
is
same
in
place.
high school. No, it isn't in high school. The high school one dips a little bit, but it's in elementary and middle school math. In 2009 to 2010, both elementary and middle school math scores dropped for just that 1 year, and then they went back up again. So did that mean everyone suddenly got stupid for a year? You know, or what?
Maybe the tests in that time were different and the questions they weren't improved yet.
Or maybe less students.
Well, this is every student in California. So we're measuring 6 million students here, right? So we're averaging across that. But I think you're right. I think the scores were just harder that year, and they put them out, or they changed something about the way they tested people, and then people probably complained, and they changed it back again. It could have been a strike or something, but yeah, across all of California, or maybe it was a really hot summer and everyone had hay fever that year, and or there was the Olympics were on TV and nobody studied or something. It would have to be something that affected everybody in the country, in the state.
I'll bet you could go and see
So
popular Google searches for that year.
Yeah, we could go. So the point here is that you've got the data, you extract it, then you have to make sense of it. And this is what data scientists do. They have to look at what's unusual and try and understand it. So I think maybe tests were harder for that year. I don't know. I'd have to do more research. And then one other thing I wanted to point out is that this is a very interesting kind of data because we're measuring the same people 3 times, right? So if you look at the people who were measured here, this is elementary school, 4th graders, and they were measured in math. But this line, which one is it? I think it's that line, is middle school. So 4 years after they were measured in elementary, they were measured again in middle school. So if we go 1, 2, 3, 4, this point here is the same as this point here. It's the same people being measured. So we can look at the people in elementary did this well in middle school. And similarly, if you take middle school to high school or something like that, all these points are linked 4 years apart. And that's a special kind of measurement, and they call it a cohort. It means that you've got a group of people and you measure them over and over again to see if their behavior changed. And a lot of what we do in data science is to figure out whether people buy more of something over time, or whether they like your new version of Netflix user interface, or whether they like, I used to work at Netflix, and that's the kind of thing Netflix does. They always want to know, are you watching more movies if we change it slightly? Anyway, so that's basically it. I'm just about out of time, so it's lunch now. So point here is that you've got these measuring people over time, and you can see how things change over time, and you can see how well students get better or worse. And I just want to think, now we went from this big block of data to those graphs. I want to show you one more thing very quickly. I won't go into great detail, which is how you have to do it. So this is a big list of data. But what I really want is to turn it into a table. And there's a thing in Excel which does that for you. And what it does is it pivots the data into a table. So it's called a pivot table. So that big long list got turned into that table that's at the top left here. And what I wanted to have was get the time down the side. So I say my row label here is academic year. So that's my row label. On my columns, I wanted math and science, and I wanted core 8 in high school. So there's my subject and my grade as my column labels. And the value I wanted in here is the percentage or the average score, and that's what I put in here. I want the average score. So you basically, the way this works is you pull things in here, and this graph changes, and then you pick a piece of the graph and you tell it to graph it, and you get the graph you want. So it's one of those things. It's a little tricky to understand and play with, but it's one of those tools that everybody has to figure out how to use if you're manipulating things in spreadsheets. And it makes it much easier than typing all the numbers in again exactly the way you wanted them, because it'll do it automatically for you. Anyway, so that was it. That's my last slide. So here's the points I wanted to make. Everything's now being measured, and huge amounts of measurements are being collected. The latest data science tools that everybody at the big companies uses are available to anybody for pennies. There's a huge amount of freely available data, so you don't have to go and join a company to get access to data. There's government data, there's weather data, there's science data, there's everything in Wikipedia. And if you pay attention in math and science class and play around with, play around with these things, learn, go through the tutorials that are available on the web, then you can get an interesting, well-paid job, hopefully. All right. Any questions? That's the last slide.
The idea is that people might pay you for that information.
People will pay you for the ability to make sense of all this data. That's the problem. There is so much information being collected. There's more than anybody can make sense of, and there's a big demand for people that can work out how to do that. But years ago, it would have cost a ridiculous amount of money to learn how to do this, and now it's available to everyone. Yeah. How long have I been doing this? So I did a physics degree a long time ago, so that's a little bit of the science part. And in physics, you learn to process small amounts of data, really. And then as computers got bigger, I probably have been doing this a few years. The whole system here started about 5 years ago. Is really when it became popular. Yeah, and it's lunchtime, so we can continue.